Hello and welcome to today's European SharePoint Office 365 and Azure Community webinar. My name is Shane and I'm delighted to be joined by Stefano Tempesta, Microsoft RD and MVP at Avanade UK, who will be talking to you today about secure multi-party machine learning with Azure Confidential Computing. Remember to join in the conversation about today's webinar on Twitter. Our Twitter handle is @EuropeanSP and our hashtag is ESPC19. Don't forget to check out the Resource Center. This is updated daily with the latest blogs, ebooks, webinars, and how-to videos. Simply visit sharepointeurope.com and click the content link at the top. After the webinar, we will have a questions window. Questions will be selected and answered at the end of the presentation. This webinar will be recorded and added to the Resource Center where you'll be notified by email when it is available. And now I'm going to hand you over to our webinar presenter, Stefano Tempesta. Hello, Stefano.
Hi, Shane. Thanks for the introduction and welcome everybody. So today is really a long title for this webinar, but in a nutshell really is a use case where different technologies have been put together to address a very specific challenge in the healthcare. Now, the use case that I'm going to present is among several health institutes, hospitals, clinics. I can really be applied in similar contexts where there is a need for computing some machine learning algorithm among multiple parties. And these parties say, I wouldn't say don't trust each other, but I would prefer to say they don't want to disclose their confidential data with the other parties. So health institutes, in this case, they have patient data and they don't want to disclose their own patients with other institutes. You can apply similar concept also to financial institutes where there is some sensitive information that is proprietary of the entity itself and they don't want to disclose it. Hence, SQL Server. But not just the regular SQL Server, an encrypted version of SQL Server. And not just the encrypted version of SQL Server, the encrypted with secure enclaves. So let's go and try to understand what all these elements are in this solution. What is a machine learning that is multi-party? What are these parties? What are these SQL Server that is encrypted? And what are these enclaves? Here we go. So the use case can be summarized in this picture. I mentioned is about the healthcare, something that I have implemented a few months ago, probably it was at the beginning of this year. So funny that I managed to get to the last webinar of the year to share this with the community. Now, these institutes were basically had a challenge. They were processing thousands or hundreds of thousands of records about their patient using a machine learning system, machine learning services that was deployed in the Azure cloud to try to identify some patterns and in this data set and make some predictions. I have an example that I will show you later. And these predictions can be of any type, whether a patient will turn some symptoms into a disease or if they will respond to a specific cure. So there are some elements of investigation. Now, what's the situation here? Each institute has its own patients. Typically, a patient stick to the same institute. It's not like they shop around and go in different hospitals or clinics, and is unlikely. So for this reason, this information remains within the institute itself. Now, the challenge, you may guess, is that machine learning works well when you have a very large data set, when the statistics can be extrapolated from patterns, from trends in this data. And for doing that, it works better when your data set is in the range of millions of records. Now, this is not the case. And the result was that the level of accuracy of prediction of machine learning was setting between 80–85%, which is still okay, but we're talking about health here, so you want to be very careful not to create false positive and not to create conditions for concern in your patient. So you want the accuracy to increase. So how about we collect together all these data sets? We have 3, 4, 5 different private institutes that operate in the country. How about they collaborate rather than compete? So they will share this information, and you get 100,000 records from hospital A, another 200,000 from hospital B, 500,000 from hospital C. You put them all together and you get your million records at the end. Now, the challenge, though, is privacy. This is quite obvious. I really don't want to share patient data.
Hi, Stefano. Your audio just keeps intermittently cutting out. Is there any chance you can connect via Ethernet, maybe? I think it might be a Wi-Fi issue.
Okay, you're breaking up a bit. Let me see if it gets any better in another location.
Or move closer to the router, maybe. Sometimes that can help.
Close, but yes, thanks for letting me know. Let's try again from this side. Okay, so I'm saying these patients this hospital have patient data, and this is something that is sensitive, and we don't want to share with other institutes. Now, it's not about sharing personal information, because obviously this is more than private, so they will never be shared, but even statistical information, so what kind of conditions, disease, illnesses these patients have is still considered a medical record. So even if it is anonymized, so we don't want to share that as well. So the solution basically consists of encrypting your data. But now, if you encrypt your data, you need to make this data available to machine learning and decrypt. So we need basically to create a sort of a trust between all the different parties that can share this encrypted data and store it in a place that is not accessible by anybody else except machine learning service itself. This is what we call an enclave. It's an environment, a place, I'll get more into details in a moment, that provides access only to a service that has a specific key to access this space, this enclave. And this is the machine learning system, the service. No one else or nothing else can access this space, not even the administrator of the operating system where the machine learning is running. And this is very important. At the end, because the machine learning service, the software that is running this machine learning service has the key to access this enclave, it will be able to work on a combined data set and improve the accuracy of prediction. All right, so let's start from data. You are probably familiar with encryption of data at rest and in transit. We can encrypt files, database, and we can encrypt also data in transfer, say over HTTPS, for example. That's pretty solid technology in the industry. What not everybody may be familiar with is the concept of encrypting data in use, so data that is in memory, running in memory and being used by an application in that specific time. So when data is at rest, is not being used, then data is transferred and is loaded in memory But when data is in memory, it's actually accessible if you have a debugger or an application that can read portions of memory. And it's visible certainly to an administrator that can run some profilers on the operating system where the application is running. Now, this can be a weak point. So we want to make sure that data is encrypted also when it is in use. And this is what confidential computing does. I invite you to go on the Azure portal and look for confidential computing. There is some very good documentation there. I'll give you a pointer to the URL later. But basically, what confidential computing is basically an enclave or a trusted execution environment that isolate memory from the operating system, from the hypervisor, from anybody except from the application that has a specific key to access data and code. So we can also encrypt code inside that enclave. So it's a trusted execution environment that is completely opaque to the operating system. So not even Windows, Linux can see it, only the application with a key. And data is encrypted and decrypted in real time because from the application that is running inside the same enclave. There are two ways of doing this. There is a software base, which is basically at hypervisor level. Your virtual machine is running a specific component that can create this sort of enclaves. And there is a software development kit, I will show you in a moment, that provides the libraries for writing this kind of enclaves. Because we are talking about operating system hypervisor level, this is available in C++ only. But even more robust approach, there is a hardware extension to a CPU. It's called SGX, a software guard extension to an Intel CPU that provides the kind of encryption directly at the CPU level, at the hardware level. If you're not running, if your virtual machine, if you're not running an Intel SGX hardware, then you can still obtain this sort of protection, this enclave at hypervisor level. So your starting point is on the Azure website, confidential computing. You can easily find it. The URL is here on top. The slides will be shared after the webinar for sure. Now, there are four pillars that you can see on screen here that are key to this solution, confidential computing. It can safeguard data from malicious use because it's there only protected, protected from any other external access. Obviously, you have control on the entire lifetime of your data because it's encrypted at any stage. As we said, rest in transit, any news. Because there is only one application with a key that can access this data, it is protected and the application is responsible for the integrity of this data itself. It cannot be compromised. But the very important thing is the last one. Data and code is opaque only to the cloud provider. So what that means is that no one except the application with the key to access the enclave can access this information in the enclave itself. Not the operating system, not the administrator of the virtual machine, not the cloud provider. So you can safely share your information in the cloud with Microsoft running your Azure cloud, and they will not be able to access this information in any case. All right, a few use cases or some additional use cases before we jump into the solution itself that I want to present in this webinar. SQL Server always encrypted technology has been around for a few years now. I think it's been released the first time with SQL Server 2016. In 2019, there is a second version or an enhanced version of the always encrypted capability, which introduced the enclaves. I'm going to spend a couple of slides on that to clarify a bit more. You may have heard about blockchain as a technology used also in the enterprise. So not only cryptocurrency, but also businesses can adopt blockchain technology for creating sort of trust by technology among parties. And this is another use case that can be applied. There we go. The other one is the one that I'm presenting today. So multi-party machine learning. We have different organizations that want to leverage the power of machine learning, and they need to combine data sets into a larger data set. So it can be the accuracy of the machine learning service can be improved. And there is another last use case around sensitive IP, for example, DRM protection. So it can be used also for creating, for storing licenses in a trusted execution environment so that they can be protected. All right, okay. So SQL Server always encrypted with secure enclaves. This is actually the product name. It is a very long but specialized version of SQL Server 29. Here we go. What is it? First of all, your application connects to a SQL Server backend using typically a client driver, right? So you have your application that is developed maybe in .NET. You have your SQL commands. They connect with a SQL connection. Maybe there is a pool of connections that are created, and you have all the queries that are sent to your SQL Server and then executed on your SQL Server, and then data is returned and displayed in your application. Pretty standard. Now, where is the encryption here, and where is the enclave? Now, the value that the encryption is adding is that all these requests, so all these queries or the commands that are sent to SQL Server actually transfer in encrypted format. I have a quick demo in a moment that will show you how data is encrypted inside SQL Server, and even your query is encrypted, so a DBA cannot understand what's going on pretty much. And data obviously comes back in encrypted format as well, and the driver can decrypt this information and display on screen in plain text. Now, so far, this is always encrypted, no enclaves yet, and this technology has been available already for a few years, first launched with SQL Server 2016. Now, this second version, or this enhanced version of the encryption technology, has been also has added capability for building rich queries. If you try to encrypt data will, in SQL Server, I mean, then it will be very difficult to do any sort of queries using, pattern matching, the like condition in your where clause, or ranges, or indexing these columns, because obviously the information is encrypted, is scrambled, you can't read it. Now, the reality is that with this advanced technology, always encrypted, even rich queries will support like ranges, because the information is decrypted in real time in memory when it is in use. but completely transparent. You don't see this happening. SQL Server processing this encryption and decryption for you. This is just reinforcing the message. Now, where's the enclave? That's the massive change, because still this information, even if it is encrypted in SQL Server, it will still be available to whoever writes an application using the specific driver. Now we need to protect this information in an additional stage, in a place, the enclave, that accepts connections only from authorized applications that have a specific key. And if we look inside an enclave using a debugger or a memory profiler, we will not be able to see anything, basically. This is a screenshot from WinDebug that is looking to SQL Server.exe in a specifically memory space, and data that is being used by the SQL Server process application is completely opaque. So I can't see anything of what information SQL Server is executing in that moment. And this is because, again, it is running in an enclave, and I don't have, as WinDebug, I don't have the key to access this enclave. So how do I get a key? Now, before we answer this question, let me show you how, as a DBA, you can build this sort of encrypted query, and how this will be displayed on screen, which is in plain text. So the encryption is completely transparent. And basically, I'm now here inside SQL Server. I'm Visual Studio running a query on SQL Server, and I have these columns that are encrypted. ASP.NET application is displaying social security number and salary information. So let's consider this information quite sensitive. And then I want to make a query on a salary range, specifying the minimum and maximum salary. Now, because salary is a column that has been encrypted, you see there is a like path condition on the social security number, or a minimum less than and greater than on the salary condition. But what is important is here, zoom in a bit, see this long sequence of letters and numbers. This is the search pattern for max salary and min salary. So there is a value in there that has been encrypted. So whoever is profiling this query can see the initial part of it, but then it doesn't see the actual values. So you can see the structure of the query, obviously, that's not sensitive, but you don't see the data that are transferred to this query. And now this can be applied to different other conditions. So the important thing to understand here is that whatever query is executed against SQL Server, data is always encrypted and is decrypted only by SQL Server itself. Now, the next stage is to protect this information inside an enclave so that only a specific application with a specific key can access. So this is what is called an enclave. And to get access to this enclave, I need a specific attestation, a specific key that is issued by an attestation service. So what is this attestation service? The attestation service, there are a few attestation types that I will tell you in a moment. But the attestation service is like your domain controller, just that is optimized, is specialized for attestations, for issuing attestation keys. Your client application, using the client driver, so the connection to SQL Server, initiate a tunnel, a secure tunnel connection, and this connection through this tunnel is used for exchanging a key which is valid for the duration of a session, and all the cipher text, so basically the encrypted text in terms of queries, commands, and the result set that is returned from SQL Server itself. So now not only we have encryption in SQL Server, we also have an additional session key that has been issued by this attestation service that basically authorizes one specific application for the duration of a session to query this data. So it's not just enough to be a DBA with access to a SQL Server where information is encrypted. You also need to have this key, this session key, issued by the attestation service to be able to read information inside the enclave. So what is this attestation service? The technology behind the attestation service is called HGS, Host Guardian Service. At the moment, there are 3 ways of doing it, but overall, this is a Windows server, a bit like your domain controller. So the 3 modes, the 3 ways of doing attestations are using Active Directory, exchange of keys, or hardware level, with increased level of security. So Microsoft recommends hardware mode for production use, and the other approaches based on Active Directory, a role in the Active Directory, and an exchange of keys only in a POC or during development, because an Active Directory can be compromised, keys can be compromised when they are exchanged, hardware typically is not. And now, I mentioned a few times that there is a driver, a SQL Server driver, that is a bit special because it connects to SQL Server and exchange this information in an encrypted format and use an attestation service for obtaining this key. So this is not your normal SQL Server client, it's an enhanced version of it, which is built using the Open Enclave SDK. Now, this Open Enclave SDK, I have good news and bad news. The good news is that it's open source, available on GitHub. I'll share the link in a moment. And you can use it for developing even your own drivers or your own applications that connect to any data source. Now, I'm mentioning SQL Server a few times here because the solution is based on SQL Server, and SQL Server provides this enhanced driver out of the box. But if you're using another data source that doesn't have this sort of enhanced driver, you can build your own driver or your own connector using the Open Enclave SDK. Now, just keep in mind that the Open Enclave SDK works at operating system level, so it's available only in the C++ language. The Open Enclave SDK is open source, as I mentioned. There is a website for documentation, openenclave.io, and is available on github.com at the URL that you see on screen. All right then, so this first part was all about securing your data. Now let's see how we can read this data and process it in the context of machine learning, a machine learning service that is executed among different parties, the different institutes, the hospitals that are sharing this information. But now they are sharing in a secure way. They are sharing with a key that can access this specific data set, this patient data. This key is available only to the machine learning algorithm and no one else. So even if Hospital 1 shares this information with another hospital, the other hospital doesn't have the key to read the patient data from the Hospital 1, because again, the key is accessible only to the machine learning algorithm because they obtain this directly from the attestation service. So there is no actual physical exchange of keys. The machine learning algorithm will go to the attestation service, access the key or get a key issued by the attestation service, and this key will grant access to the enclave where information is stored. So in this way, all the different parties can share their encrypted data sources, but they are only sharing with the machine learning algorithm. So no one else in any other hospital, or in the cloud provider, or in the IT department where the machine learning algorithm is running, can access this information. So I have now some CSV file that contains some data set from one hospital, Hospital A, and there are some numbers in there. They are anonymized but still valid. So I encrypt them. Okay, so I encrypt them and then I sign in my machine learning portal. Keep it very simple here. It's just an application. I don't want to focus too much on the user experience, but more on what happens on the back end. And now I'm uploading the encrypted file. So not the one with all the numbers, although they are anonymous, but these numbers still mean something. And now I switch into another desktop to simulate that I am in another hospital. So I have still another file. I encrypt also this file, and now I sign in the same application, but with user B. So I'm in the second hospital, and I'm uploading again the encrypted file. Right now, I run the training for these two files, the training on the machine learning service. And what happens basically is that when I go and evaluate this model, so I can download the model that I trained before and then go and evaluate the model, you can see that basically the local model running from A, so the hospital one has an accuracy of 84%, but when combined together, the accuracy bumps up to 97%. So the two hospitals have their own data. It's been anonymized, but still contains some numbers, so it can be understood what it is, even if there is no reference to specific patient by name, but it's still a medical record. So I encrypt this data, then I upload this data into a portal where the machine learning service is running, train this data, and then run the evaluation. When running against one file only, I get an accuracy, as you can see, 84%. When combining together, the accuracy bumps up to 97%. All right, the final part of this conversation is around how this machine learning has been implemented. So I'm using ML.NET. ML.NET is an open source library for building machine learning services, algorithm, in C# in .NET. You can do it in other programming languages, but ML.NET fits the purpose for me, considering that I'm all running on the Microsoft technology stack. So ML.NET is available on .NET/ML. Again, is an open source library. I'm building a multi-class classification experiment here because I have multiple variables to consider. I will show you the dataset in a moment. And it is a classification problem because I'm trying to estimate the likelihood that a patient develops a conditions based on patterns of data identified in the historical dataset. As said, the single source was around 84%. It was in the range 80 to 85%, depending on the institute. When combining together, the top accuracy that we managed to achieve was 97%. This is a typical medical record that is contains some element around age, sex, whether it's a smoker or not, blood pressure, heart rate, and the output is a score and the accuracy of the prediction itself. So the score is a number between 0 and 1 that indicates the likelihood that a patient with those conditions develops a sort of illness or other conditions that the hospital should take into consideration. So let me show you a little bit how that works also from a code perspective. Let me see if this is clear enough. Maybe I can zoom in a bit. There we go. So your machine learning service starts with creating an instance of ML context. This is your base class for all your machine learning projects using ML.NET. The training, and I'm happy to share the code itself. There is nothing sensitive in here. Basically, access the data source, and I'll get back on this. Read the data source in memory, and then apply some transformation. Because this is a classification, we have to turn some of this information, like age, sex, smoker, into a categorical feature. Now, if you are not familiar with the way machine learning works, borrow data science from somewhere, because they will know how to do that. So that, but basically the idea is this information, as you have, if you remember, as you saw here, this can be a number, or can be a Boolean value, or can be a percentage, and or a indicator like sex, for example, is 0 for female, 1 for male, or I believe 9 for not disclosed, something like that. So basically, we need to turn all these variables, these features, into a number, into a categorical expression of these values. Because with this, after applying this transformation, then we are, the ML.NET library is able to identify trends based exactly on numbers. There is something here around concatenating these different features. The reason here again is that I indicate what are the labels that I want to work on. Not all the features are relevant, so I may want to consider only some of them. So I indicate the one that I want to use in the prediction, and at the end I run the training part of it. There are a few functions here to run the training itself. If I click in here, maybe intelligence should help me a little bit with the different things. Here we go. So there are a few things here that I can use, like logistic regression, naive Bayes network, and a few other ones. The one that I'm using is this stochastic dual coordinates ascent. Is a linear multi-class classification, which basically looks into correlation between age, sex, whether a person is a smoker or not, and all the other things, with the conditions itself that I'm analyzing. It's probably harder to explain with this terminology if you're not familiar. And I'm not a data scientist myself. I'm coming from an engineering background. So sometimes understanding which function to use over another one is just a matter of either having a data scientist in your team that can tell you which one is the preferred approach to use, or just trying and see which one produces the best results in terms of accuracy. The very end, I save the model after basically running the prediction itself. And when the model is saved, then I can use it for generating my output, which is in the scoring down here. So the prediction engine runs a predict method for the specific medical record. So I pass in input a medical record that is in this format, contains risk, age, sex, Boolean smoker, and all the other values, and will return a score, and this score is a number between 0 and 1, indicating the likelihood that a person identified by this medical record will develop a specific condition. Now, one step back at the beginning here, which is the key part of all this conversation. My source data, so my collection of medical records, is accessed from a data source. And particularly, I'm reading 80% of these records. Again, if you're familiar with the way machine learning works, you probably know that you don't need and you don't want the entire data set for training. You typically allocate a portion of your data for training and another one for testing. Now, the split is up to, again, the data scientists that understand the data better. Typically, the higher is the accuracy of your data and input, the better is the training, so the more percentage you want to allocate for training. I'm assuming that my data is 80% good conditions, so I'm giving an 80% split rate here. Again, this can be tuned to see to improve accuracy over time. And you certainly don't want to hard code the value in here as I did. You may probably want to pass this as a parameter in input to this function. There are margin of improvements on this code for sure. Now, where is this data coming from? It's coming from this medical record data source. Now, and if you have developed application that connects to SQL Server, you will find these extremely familiar. You're basically creating a SQL connection for this connection string. You open the connection, create a command, assign a query to this command, execute the query, and if the query returns a data set in a data reader object, so if there are any rows, read until the end all the medical records that are available in the data source and input. So where's the special SQL Server encrypted? Where's the special enclave with the attestation? Well, the magic is inside this SQL connection, or more specifically, is inside the connection string. So this connection string is coming from down here. It's coming from my configuration manager, so it's coming from my web config file. If I go into my config file, I have anonymized my database here. My data connection string contains my initial catalog. This is your database name. The more important thing is this one at the end. So you put column encryption to enable and enclave attestation URL pointing to your host guardian service. Okay, oops, sorry. It's a bit tricky with the zoom in. Here we go. So this enclave attestation URL is your attestation server. This attestation server exposes a service that is available at the URL /attestation. So you just have to make this available between your application, so your application and the station server, and then the station automatically started.
We seem to be having a few technical difficulties there. Just bear with me as we try and get Stefano back. Hello, Stefano. Stefano, your audio seems to be giving trouble.
Did you miss just a bit? Shane, did you miss a lot of the final thing?
Yeah, you're fine. You're back again. We just had some interference there. Okay, please continue, Stefano.
All right. I'm really at the end. So basically, just repeat myself on the last part in case you missed it. This enclave attestation URL in the connection string is what makes the connection between your client application to the attestation server possible. So when in here I create an instance of my SQL connection driver, the SQL connection driver automatically calls the attestation server to obtain the key to access the database server in here. So this brings us to the end. We have time for a few questions, and as usual, available after this webinar on the usual channels, Twitter, LinkedIn. Please get in touch. Slides and a recording of the presentation will be shared. Any questions?
Thank you. And answers part, and should you wish to ask Stefano a question, please type it into the questions window now. Okay, Stefano, here is a question for you. Can we code the machine learning component in another programming language, for example, in Python?
Yes, we can certainly do that. So the example that I show now was based on ML.NET using C#. And the reason is, well, first of all, I'm familiar with this programming language, and I can use the SQL connection driver, the enhanced version, out of the box with no modification. Now, I'm personally not familiar with Python, but if Python has a library for connecting to SQL Server and that driver has been enhanced to support a connection to SQL Server 2019 with secure enclaves, then you're good to go. I know for sure that the SQL Server driver is available as a managed package for .NET, also as a JDBC, so Java application will work, and also as an ODBC, so any other application will work as well. So I'm pretty sure that Python or any other programming language will be okay.
Okay. Can I use Azure Machine Learning Studio to connect to a secure enclave in SQL Server and run the machine learning service in the cloud?
Right. Okay. This is different though. My ML.NET code here is running in a virtual machine, or it can be in a container that use the SQL connection driver in enhanced version for SQL Server with enclaves. I don't believe Machine Learning Studio has support for enclave attestation just yet. I can double check, but the last time I used Machine Learning Studio wasn't the case, and this is one of the reasons also why, when at the beginning of the year, when we work on this project, we couldn't use Machine Learning Studio because it's a software as a service running in the cloud, so you can't decide which driver you want to use. You just get what you get directly in Machine Learning Studio. So this is why we had to opt for ML.NET running in a container.
Okay. Is there that is supported?
Encryption. So this is a question related to the first part, when the data has been encrypted and then uploaded for training. No, not really. That is completely up to you. My recommendation is to use an asymmetric encryption, like RSA, for example, because then you don't have to share the encryption key between the parties, but any encryption will work, really.
Okay, brilliant. On behalf of the ESPC community, thank you, Stefano, and everyone for taking the time today to complete this webinar. We really appreciate your time, Stefano.
My pleasure, Shane. Thanks, everybody, for attending.
Thank you. Okay, everybody, that is the end of the webinar today. Please see sharepointeurope.com for further details or resource center for all previous episodes. Thank you again to Stefano Tempesta, and thank you for joining us today. Take care and goodbye.